Hello, guys, and welcome back to another lesson with Mr. Sanchez. Today, we're going to be doing section 4.5. This is part one of analyzing the graphs of a rational function. Okay, our learning target is very straightforward. Analyze the graph of a rational function. I've actually broken this down into 6 steps, and by I mean the book. So this is our step-by-step process. Let's go ahead and read it before we go over it. It says, first it says, factor the numerator and denominator of R. After you factor it, you're going to find the domain. So basically, first step is find the domain. Write R in lowest terms. That means cancel out any. So after you factor it, if you see any common factors, you're going to cancel those out. Locate the intercepts of the graphs. We need to find our X and Y intercepts. We're going to use multiplicity to determine the behavior of the graph of R at each x-intercepts of the multiplicity is even or odd, touch or cross. Step 4 says to locate the vertical asymptotes, determine the behavior of the graph on either side of each vertical asymptote. So we determined the behavior based on multiplicity. So I'll go over that. This part, that's why I have a little star, okay? Step 5 says locate the horizontal or oblique asymptotes. Determine points, if any, at which the graph of R intersects this asymptote. Okay, and then graph R, we're going to test some points, but you're going to see we're going to be doing some nice sketches. What I mean by section 4 is so if we look at this problem here, at this graph, you're going to notice that the multiplicity of this is 1, right? So whenever you see the multiplicity of a vertical asymptote be 1, they're going to be going in opposite directions. And by 1, I mean odd. Sorry. So they're going to go in opposite directions. Our graph could technically also go like this if we had like a negative in front. Okay. Whereas if the multiplicity of our vertical asymptote is even, right? So it's even right here. That means we're going to be heading towards the same direction. So if I had a negative here, then we'd be both going this way in the negative direction. The multiplicity of our vertical asymptotes determine that. Okay, and we're gonna have more examples, so don't worry if that's a little confusing. And if it sounds like I'm rushing it, we have some long examples today, so I just don't want us to get caught up in any of that. Okay, hopefully you take a moment, pause, and write this down, and let's move on. All right, so the first problem says analyze the graph of the rational function. All right, so step 1. So step 1 is to rewrite this in lowest terms, right? And then find the domain. So R of X is equal to X minus 1 over X squared minus 4 is the difference of squares. So we can rewrite this as X plus 2, X minus 2. Our domain is X such that X cannot equal negative 2 and X cannot equal positive 2, right? So we can't equal negative positive 2. So X can equal negative 2, X cannot equal positive 2, right? So that's how we find our domain. Step 2 is to write in R in lowest terms. It's already in lowest terms. Already in lowest terms. Okay. So nothing about that. If lowest terms would be if we had a plus 1 here, and so we had a X minus 2 here. We'd cancel those out. That's what lowest terms means. Step 3 is to locate any intercepts, right? So we're gonna find the y-intercept is when X equals to 0, right? So what happens when we have X equal to 0? We're gonna have 0 minus 1 over 0 squared minus 4. So our y-intercept is gonna be 1 over 4. So 0 comma 1/4. That's our y-intercept. And our x-intercept, right? Our x-intercept is when we let the top equal to 0. We're gonna get X minus 1 equal to 0, which means X equals to 1. So our x-intercept is 1 comma 0. These are our intercepts. And if you look at this has a multiplicity of 1, so it crosses. All right, step 4. Ooh, we're gonna need a lot more space. Step 4. All right. Step 4 is to locate the vertical asymptote. So that's kind of easy. It's wherever our it's wherever our domain we have divide by zeros, right? So our vertical asymptotes are going to be x equals to 2 and x equals to -2, right? And since because they both have multiplicity of 1, we know that our graph is gonna at our asymptotes, we're gonna go like this or like this. We'll find out which way in a bit, right? So wherever our vertical asymptotes are, we know we're gonna go like this and like this, or something like that, something like this, and we'll see which one in a bit. Okay. All right. And then step 5 is to locate our horizontal asymptotes, right? Step 5 is pretty easy because if you look here, our denominator, it's bottom heavy, right? So because the degree here is 1 and the degree on the bottom is 2, that means that our horizontal asymptote, when n is less than m, that means that our horizontal asymptote is y equal to 0. All right. You're gonna realize that when we equal to 1, all right, and then after that it says determine any points in which the graph intersects the intercept, right? So because we're trying to figure out if we cross this, although we have a horizontal intercept, we gotta find when if we have crossed it, and we do cross it once at x equals to 1. All right, so well, since it's a horizontal asymptote, normally what you do is you're gonna do x minus 1 over x squared minus 4 equal to 0. We're trying to figure out when this equals 0 to find out if all the points where we cross, because we gotta multiply both by x squared minus 4 to both sides. All right, this goes away, that goes away. You're gonna get x minus 1 equal to 0, x equals to 1. So we only cross our horizontal asymptote at this point. All right. And then last but not least is to graph, okay? We're gonna go ahead and move, I'm gonna go ahead and move this a little bit further down. We're probably gonna need a new problem, need more space. Let's see. Okay, so now we got a graph. Step 6 is graph, okay, guys? So let's start out with all the information we do have. Right, so we have our vertical, we have our x and y axis. Ta-da. Right, we have our vertical asymptotes at x equals 2 and x equals -2. So at 2, oops, we have our vertical asymptotes like this. And at +2, we also have our vertical asymptotes. And we have a horizontal asymptotes like this at a 0, right? Let's plot some points we know. We know that our x-intercept is 1, 0. So at 1, 0, we cross right here. And we know that our horizontal and our vertical asymptote is going to be 0, 1/4. So we're going to cross right here, somewhere right here. Because it's like this, all right, now we can just use common sense to go over this, right? So we got to cross at the intercept, right? So because we cross, we're going to go down here this way, and this is going to eventually curve back upward. We're just guessing, we don't know the entirety of the graph, okay? Because our multiplicity here are for vertical asymptotes are odd, that means that our graph here has to come from the opposite side. So right here, we're going up. So our graph has to come from down here. So we don't even have to draw the actual graph. We can, but we do want to find a point. So to make our graph a little bit more accurate, we're gonna let x equals 3 and find out what happens. -3 and find out what happens. So our original graph is -3 minus 1 over 9 minus 4, which gives us, I guess, -4 over 5. So at -3, we're going to be down here, right? And we know that our graph is gonna go like this. Okay. And then I'm not gonna test 3 comma 0. You can find out what happens when x equals 3. You're gonna get 3 minus 1 over 9 minus 4, which is going to give you 2 over 5, right? So smaller here. But you should know because our asymptote has a multiplicity odd, since we're going down, we gotta come from the top. Okay. So we're gonna go ahead and just draw our graph going like this. And that is our sketch. All right. It's a pretty easy graph, okay? I know this is tough. We're gonna have some time to practice this in class, guys. So let's go on ahead and do our next problem, which is problem number 2. So I'm actually gonna erase all of this. Make sure you copy it all down, obviously. So make sure you pause. So let's see, I can just do this. Ta-da. All gone. And we're gonna try and move this to the top. All right, we're gonna do problem number 2. Oops. Problem number 2. And if you're wondering, is this a long video, mister? Today is a long video. All right, so once again, we gotta do step 1, which is to, and I have the book here just in case I get any step wrong. Rewrite the top and bottom we want a factor, right? So that's the difference of squares. So we're gonna do x plus 1 over x minus 1 over x, right? What's our domain? Our domain is x cannot equal 0. X such that x cannot equal 0. Right. Step 2 is to write in lowest terms. It's in lowest terms. So we're lucky there. I think in the second part of this lesson, we're gonna go over what happens when you don't. All right, so we gotta find our intercepts. So our x-intercepts is easy. It's when x minus 1, x plus 1 times x minus 1 equals 0. This is our x-intercept, right? So that's when x equals -1, x equals +1. That's when we have our x-intercepts. So -1 comma 0, 1 comma 0, and it touches, right? So for our y-intercept is when our y is, what happens when y equals 0? As you're gonna notice that when y equals 0, y cannot equal, when y equals 0, we're gonna let the bottom equal to 0, right? So x cannot equal 0. And if you look at our graph, you look at this right here. If we let x equal 0, that's not in our domain. So there is no x-intercept. No, I mean no y-intercept. Okay. Now step 4. Let's see what step 4 is. All right, and you can refer back. Step 4 is to go over the real zeros, right? No, let me double check, because for some reason I'm having a brain fart. Step 4 is to locate the vertical asymptotes. All right, vertical asymptotes are, do we have any? Yes, we do. Do we? We'll find out. Yeah, we do. Our vertical asymptote is when the denominator equals to 0. So that is when x equals 0. And determine the behavior of the graph on each side, right? So because it's a multiplicity of 1, we know that wherever our graph is, we're gonna go like this. Opposite directions, right? All right, step 5 is, what is step 5? Find the oblique asymptote, I guess. All right, so if we look at this one, and our degree here, our top is 2 and our m is 1. That means we got to use long division to find the oblique asymptote. So since it's x squared minus 1, You're gonna divide x squared minus 1 by x, right? So remember, because there is no x term here, you gotta basically put 0x minus 1, right? This is a placeholder. All right, so how do we get x squared? We're gonna multiply both sides by x. You get x squared. Bring that down. That's gonna give you 0. You bring down the 0. You bring down the -1. -1 over x. So this here is our oblique asymptote. Our oblique asymptote is y equal to x. Because remember, you get x minus 1 over x. We don't care about this part. Okay. That's our oblique asymptote. What is step 6? Step 6 is to graph. All right. No, it's not. Yeah, it is. Step 6 is to graph. So step 6, let's draw our graph for those things that we know. Okay. Ta-da, step 6. So what have we figured out about our graph? So things we know. We have a vertical asymptote as x equals 0. So that is our vertical asymptote. We have an oblique asymptote at y equals x. So that means there's going to be an asymptote right here. It's like you draw the graph. If you don't know how to draw graphs, it's just slope intercept for, right? And then next up, we got to find our y-intercepts, our x-intercepts, I mean. We have an x-intercept at -1, 0, and a y-intercept at 1, 0. Now, because the way the graph works, if you look at the graph, the smaller x gets, right? The smaller this gets, my bad. I'm sorry, guys. The bigger x gets, the bigger x, the whole thing will go because the numerator is getting bigger. So we know that this graph is gonna go like this because it has to cross, right? And since we have to cross and we can't cross like this, we gotta cross like this. And that's our graph. Okay. We know we can't cross our intercepts, and we know we gotta cross at these points. So because we cross here and we cross here, we know we can't go this way because our intercept one, our asymptotes won't let us. And that's the graph of the third one, of the second one. I know this is really complicated, guys. So if you're struggling, don't worry. You're gonna have time to practice this in class all day. All right, let's go to the next one. Our last example for today, which is this one. All right. So step 1, write in simplest terms. And by that, I mean factor. So x to the 4th to the power of 1. And it's already factored completely because this is even, right? So we can't factor it anymore. So we're gonna leave it at x to the 4th plus 1 over x squared. Okay. One thing you're going to notice is that our domain is the same. Our domain is x such that x cannot equal 0. Let's go to number 2. Step number 2 is write it in lowest term. It is in lowest terms. What's step 3? Step 3 is to find our intercepts. So we have no y-intercept since x. We gotta get x plus 4 plus x to the 4 plus 1 has no real solutions, right? So we want to find our y-intercept. We gotta do x to the 4th plus 1 equal to 0. This is for our y-intercept. Because this is an even power and you have plus, it has no solution, right? Therefore, no y-intercept. But we can't find our, no, that's for our x-intercept, my bad. That's the top. The top is for x-intercept. For y-intercept, we just let x equal 0. But guess what? We have no y-intercept. No y-intercept because x cannot equal 0, right? So we have no intercepts. That's an odd one, right? What is this going to look like? You're probably wondering. Well, let's go to step 4 to find out some more stuff. Step 4 is to locate the vertical asymptote. Our vertical asymptote is x equal to 0, right? And then step 5, let's find our oblique asymptote, right? So it's very similar to the last problem. All right, so let's find our oblique asymptote. So step 5. We actually, our n is 4 and our m is 2. So it has no oblique asymptote, right? It has no asymptote, as a matter of fact. But we do know that this, it has a different thing, right? So what we got to do is we got to look at this function is going to closely resemble this. We have x to the 4th to the power 1 over x squared. It's going to closely resemble the power function of the top and the bottom, right? So x to the 4th over x squared is actually x squared. So we're going to have a different type of asymptote where we're never going to intersect the graph of y equals x squared. And you're probably wondering, what does that mean? What does that mean? Y equals x squared. So we do not touch this graph. So that basically, we're going to copy the behavior of this graph. Okay. So what we're going to do is we're going to draw what we know. So what do we know? We don't have enough on this one. You're probably wondering, Mr. Why are you messing with us? Okay. So what we do know is that our vertical asymptote is x equals 0. But we're also going to have this other type of asymptote, and it's y equals x squared. So at 1, 1, and at 2, 4. So 2, 1, 2, 3, 4. So our graph is actually going to have an asymptote that looks like this. Right? And one thing you're going to notice is that at the here at our vertical asymptote, the multiplicity of our vertical asymptote is even multiplicity, right? So because the multiplicity is even, you're either going to go like this or like this, but wherever we approach the asymptote at the same direction, right? So we know we're going to be coming this way. Oops. We're going to be coming this way. We're going to be heading to infinity this way. And if you actually plug in some values, so we plug in x equals -1, you're going to get 1 plus 1 over 1, which is equal to 2. So a -1, you're going to get 2. And a +1, you're also going to get 2 because it's even. So our graph is actually going to go like this. It's going to curve that way. And if you don't believe me that this is what happens, you can try x equals +1. That's going to be 1 to the power 4, which is 1, plus 1 over 1 squared, which is 2. All right. So this here is 1, 2, -1, 2. And that's what our graph is going to look like. No, I know it's a lot. You probably have a lot of questions for this, which is why we're actually going to go over this in class. And so you're probably watching this. You're probably going to be watching this after class. You have a lot of questions. I understand. Feel free to let me know and we'll go over everything. All right, guys. Have a great day. Bye-bye. This is the lesson. I know only the first test. Bye.